Hello everyone, I am Janani. In today's video, we would be covering a topic known as Pascal's triangle. So, what is actually a Pascal's triangle? A Pascal's triangle is a triangular array of numbers which begins with 1 and ends with 1. The values between the ones are going to be the sum of the values in the preceding row. So, for example, this is a 4-row Pascal's triangle in which the first row is going to be 1. The second row is going to have 1 at the left side and 1 at the right side. The third row is going to have 1 at the leftmost side and another 1 at the rightmost side, and the middle value is going to be the sum of the values in the above row, that is sum of 1 and 1 is 2. Then the last row is going to again contain 1 at the leftmost side and another 1 at the rightmost side, and these 3's are going to be the sum of the values above it, that is this 3 is going to be the sum of 1 and 2. And this 3 is going to be the sum of 2 and 1. Our task is to write a recursive function which will take the row number as input and produce a corresponding row in the Pascal's triangle as output. So, let us see the test cases. The first test case has an input of 3. So, the row 3 of the Pascal's triangle would be 1, 2, 1 as we saw above. Second test case is having 4. The output is 1, 3, 3, 1 as we saw in the Pascal's triangle. So, similarly we can increase the size of the row and the output size will also increase. Before moving on to the coding part, let us see the algorithm which we can use to compute the row corresponding to the row number from a Pascal's triangle. So, first of all, we have to know how the Pascal's triangle is actually constructed. As said before, the Pascal's triangle basically has 1 at the leftmost side and 1 at the rightmost side, and rest of the values which lie between those ones would be the summed values from the previous row. So, for the first row of the Pascal's triangle will have only 1. The second row of the Pascal's triangle will have two values, that is 1 at the leftmost side and 1 at the rightmost side. The third row of the Pascal's triangle will have a 1 at the leftmost side, 1 at the rightmost side would be the sum of the above values, that is 1 plus 1, 2. Now, if we move on to n equals to 4 case, then we will be having 4 spaces, that is 1, 2, 3, 4, in which the first value is 1, the last value is 1, the second value is going to be the sum of 1 and 2 which is 3, and the third value is going to be the sum of 2 and 1 which is 3. We will write for another case, that is when n is equal to 5, the first value is going to be 1, the last value is going to be 1, there would be 3 values in between them. So, the second value would be the sum of 1 and 3 which is 4, third value is the sum of 3 and 3 which is 6, fourth value is the sum of 3 and 1 which is going to be 4. So, now we have to construct an algorithm which will take the row number as input and produce the corresponding row from the Pascal's triangle as output. So, here the base case would be for n equal to 1. So, if the base case would be if n equal to 1. So, if n equal to 1, then we have to return a list which is going to contain only 1. But if n is not equal to 1, that is if n is not equal to 1 and n is greater than 1, then we have to iterate over the previous row and sum up the values from the previous row and append it inside a list which is going to contain only 1. So, if n is greater than 1, we will be having a default list which is going to store only the value. To this list, we have to append the elements by summing up the values from the previous row. So, for example, if the value of n is given as 3, we have to have a variable known as pref which is going to store the previous row of the Pascal's triangle. So, here n is 3, the previous row would be corresponding to the second row. The second row is having the values 1 and 1. So, it would be 1, 1. And now we have to compute the new line by appending the elements to this list that is containing only 1. So, now by default we will have a list which is containing only 1. To this we have to append the sum of the elements from the previous row. For this case it is 1 plus 1 which is going to be 2, and this will correspond to 1, 2. Once we are done with appending the elements by summing up the values from the previous row, finally we have to return that list, that is line, plus an additional 1 which is appended at the end, as the Pascal's triangle always begins with 1 and ends with 1. By default we will be starting the list with 1 and then we will be ending the list with 1. So the final answer would look like 1, 2, 1. So in the let us do the same for n equal to 4 to understand better. So initially when n is going to be equal to 4, the prev is going to have the values of the third row, that is 1, 2, 1. Now the line will be having the value only 1. Now to this line we will be appending the summed values from the previous row, that is first we will append 1 plus 2, that is 3, then we will append 2 plus 1, which is going to be 3, and finally once we are done with summing and appending, we will append an additional 1 at the end to compute that particular line. So the final answer would be 1, 3, 3, 1. So now let us try coding this question. Let me create a function known as Pascal which will do the task. Here this n is going to accept the row number of the Pascal's triangle as input, and now if the value of n is going to be 1, we will just return a list which has only 1. So if n equal to 1, return 1. If the size, if n is not going to be equal to 1, then we have to sum up the values in the above row and then produce the output. So else we will create a line which will have only 1 in the list as of now, because every line in the Pascal's triangle is going to begin with 1. So line equals to 1, and after doing this we have to iterate over the previous line and then sum of the values in the previous line and then append it into this line. So this can be done by first accepting the previous line as input. So to accept the previous line as input, we will do previous line equals to Pascal of n minus 1. Note that here the Pascal of n is going to return the nth row of the Pascal's triangle. Here Pascal of n minus 1 is going to return the n minus 1th row of the Pascal's triangle. So now we have taken the previous line as input. We will iterate over the previous line and then append it into the line. For I in range of len of previous line minus 1. Now we will append the added values from the previous line, line plus equals to previous underscore line of I plus previous line of I plus 1. So we have to append it inside the list. So I am enclosing this within square brackets. After doing this, the final digit in the row should be 1. So we will come out of the for loop and then append a 1 at the end. Finally, once we are done computing the row, we can just print it. Now let us try running it for one case. Okay. So when I give Pascal of 2, it is returning the second row of the Pascal's triangle. Now if I change the number to say 6, it is returning me 1, 5, 10, 10, 5, 1. Which is the expected output. So we have seen the way to compute the row of the Pascal's triangle using recursion. Thank you.